Screencast number 4, covalent bonding. We're going to talk about molecular geometry, which really means the shape of molecules. What factors affect the shape of molecules, and how can you predict the shape of a molecule just from its Lewis structure? Essential questions. All right, 3D shape of molecules. It's based on this theory known as VSEPR. We call it VSEPR even though it's spelled a little differently. Okay, VSEPR. Valence shell electron pair repulsion theory. Electrons, as you know, are negatively charged, so electron pairs are going to repulse each other. Okay, so the repulsion between electron domains on the central atom in a molecule causes them to be as far apart as possible. Okay. It makes sense because electrons negatively charged, they're going to be 3D in 3D space as far away from each other as they can be. We're going to define electron domains as lone pairs of electrons or bonded electrons, and those bonded electrons can be single, double, or triple bonds. Each of these count as just one electron domain. Okay, so example, let's look at CH4. It's known as methane. I can see that around the central atom carbon, I have 4 single bonds. So that is 1, 2, 3, 4 electron domains. Those electron domains are going to be as far away from each other as they can be. And that is a tetrahedral shape. Okay. On the Lewis structure. Okay, the Lewis structure will give us a clue as to what the shape is, but it can't give us the shape because the shape is actually in 3D. There'll be examples in class to show you what each of these things look like, or you're going to be asked to build them, one or the other. All right, but in 3D, the bond angle, meaning the angle between 3 atoms, is 109.5 for a tetrahedral. All right, and this is what's called a tetrahedral. Okay, what is the impact of lone pairs then? If I look at water, I have 2 pairs of bonded atoms. I also have 2 unshared pairs. Remember, definition of electron domain, those are 4 electron domains. So these electron domains affect this shape because I'm still having the one and then the one that goes out in the back. So 4 electron domains make the electron domain shape tetrahedral. But because you only look at the shape of the actual atoms that are bonded, for this molecule you're just looking at this, and this is called a bent shape. Okay, so the name of the shape refers to the atoms only. The lone pairs definitely affect the shape of the molecule. So sometimes what I find helpful is to talk about the electron domain shape. And then the next step is to actually talk about the molecular shape. Okay, these two things can be the same. Frequently they are different. So the electron domain shape for water is actually tetrahedral, but because only 2 of them are bonded, the molecular shape is bent. But these unshared pairs force these 2 bonds to be pushed together. Oh, I wrote all over that. All right, so the shapes you need to know: linear, 2 electron domains, okay, with atoms on either side. Then trigonal planar, 3 electron domains. These are all in the same plane, hex planar. Okay. Bent, you can have a bent with an electron domain being trigonal planar, but only 2 atoms bonded. Okay, bent. And then trigonal planar has the 3 atoms on all sides. Tetrahedral shape, again, 4 electron domains. Each one of them has an atom, so it's tetrahedral. If I have 4 electron domains, the electron domain shape is tetrahedral, but because I only have 3 atoms connected, it is trigonal pyramidal because this electron domain forces the others off of the plane. And then I can have a bent domain with a tetrahedral electron domain, but only 2 connected, making it bent. Hopefully working with models will make this easier to see. Okay, so practice. Draw Lewis structures for these 3 and then use the table to determine the shape. You will need to memorize the table and how to determine the shape from a Lewis structure. Pause the screencast, do the Lewis structures, and then use the table to determine the shape. Okay, you should be back from trying this on your own. So for the carbon tetrachloride, that would be the Lewis structure. If you look at this Lewis structure, hopefully you'll see that I have 4 electron domains. Each one of them has an atom connected, so this should be tetrahedral. Okay, tetrahedral, good. Looking at pH 3, here's the Lewis structure. Looking at the electron domains, I have 1, 2, 3, 4. Of those, I only have 3 that have an atom connected to it. So looking at the table, you should be able to pick up on it being a trigonal pyramidal. CO2, Lewis structure is this. I have 2 electron domains. Those electron domains both have atoms connected. Looking at the table, you should pick up that that will be a linear molecule.